So we've done all this work with lines, straight lines, looking at their equation because it's a perfectly straight line. We can find its equation, okay? Just to let you know, there are all kinds of other types of special lines in the world that come up with other things. Like one really famous thing is gravity. Has anybody ever heard of gravity? No. You throw a ball in the air, it follows a really special kind of curve that you can learn to graph, and you can learn to do all the same stuff that we did, where it starts, where does it go after that, that kind of stuff. But it's a lot more complicated. You will talk about it in grade 10. And if you were to study mathematics through university or beyond, you would learn about all kinds of lines and how to model them. So we, in grade 9, we just look at straight lines. But we get a really good sense of how to model real world things with mathematics, right? And so things like, okay, so I understand that a taxi costs this much. And so if I were to go in that taxi for 30 kilometers, how much would it cost me? Right? That's the value that it has in the long run, is you can solve real world problems. We've done a lot of that, a lot of these straight lines. But the other thing that happens, and you've probably already, if you have science this semester or even from elementary school, that you've probably seen this already happen. And if you haven't had science yet, you will, and you'll definitely see this happen. Is that when you take your own measurements, so if you were to throw a ball and time how long it was in the air or whatever, and you wrote down those measurements, or like even when we did the cup stacking activity, if you took a bunch of measurements, that one's pretty good. If you take careful measurements, you get a pretty good measure, like you get pretty good numbers. But often if you're doing your own experiment and you're measuring your own things, when you put them into a table, you get something like this that's not a perfect straight line. Do you see what I mean? Because, like, in real life, when you're measuring things, it's not going to be perfect. Things like the cost of something or how much money you make per hour is, because that's calculated. You make $10 per hour. But things like measuring how far you throw a ball or whatever it is, okay, isn't going to form a perfect straight line. So we call that a scatter plot. Why do you think it's called a scatter plot? Because the points are a little bit more scattered than making a perfect straight line, okay? But the thing about so this is a whole different branch of science and mathematics. We're only really spending one day on it. But the thing about it is, I can still look at that and say, you know what? It's not a perfect straight line, but it's kind of a line. Don't you think it's kind of, those points are in a bit of a line? They're just off by a bit? Close enough? So we still can do math on scatter plots, and we still use them to look for what we call trends, which is going to be kind of an important part of what we're going to talk about today. It's thinking about a trend in data. We can actually draw a line through the middle of those points as best as we can, and then the line that we draw, we could do the same kind of math that we've been doing. We could pretend that that line represents all these points, even though they're off by a little bit. So some things we might do, if you had this on paper, is I might draw a circle around, like really tight circle around all the points. And then when I look at that circle, it's going like this. I would use my ruler if I was doing it properly. We're going to practice this, but like there's my line, okay? And I would extend it, and so it might be going through 0. They don't always. This one might, but it's one of those lines that we're very used to. So each one of these points is off of the line a little bit. Some of them are right on the line. Some of them are off the line. So it's not perfect, but it's like an average. You've talked about averages, Ethan? You've talked about averages in elementary school. You understand what an average is? So this is called a line of best fit, and it's like an average of a scatter plot. Okay, so here's where you're going to have to do some thinking. What do you think those points could represent? Because there's no label on these lines. So some people, when your teacher asks you to think, you don't think, you just sit there and wait for somebody else to answer. I would really encourage you to try to come up with your own answer right now, because if you have to do this on a test, you want to have practiced. What could those points represent? Be creative. This can be hard. Tariq, you had your hand up. What do you think? So which one of those is distance? So this here is distance. Like if this is distance, then what's this? Time. So the longer what? The longer time it's in the air. So this was not in the air for very long and didn't go very far. This one was in the air longer and went farther. This one was in the air, the time was the longest and the distance was kind of tied, but was one of the longest distances. Is that what you mean? Yeah. That makes sense? I like it. Good. So if this was distance and time, I would say the longer the ball was in the air, the further it went. I'm going to do a little experiment here. Just watch. Okay? How long is this ball? It's an eraser, but how long is this in the air?
1 millisecond.
0.5.
Not very long. How far did it go?
Not very far.
Not very far. Okay, how long is this in the air?
25.6 seconds. 2.5 seconds.
Longer, and it went farther? But what about this?
2 seconds.
Didn't go very far, and it was in the air the longest.
3 seconds.
So again, that's what we mean by a scatter plot. I could throw a ball so that it wasn't in the air, it was in the air very long, but didn't go very far. So sometimes we have these points that are way outside the data. Most of them are in this line, but that one was Mr. Belair being screwy and doing it wrong, right? Like I wasn't doing the experiment the right way or whatever. Okay, good. What else could this represent? Come up with something totally different. Can anybody else think of something where the bigger it gets one way, the bigger it gets the other way? The amount of chickens you ate? Compared to what? Amount of days? Okay, this is really weird, but this is number of days. And this is number of chickens eaten. No problem. Oh, yeah. Okay, that could work if you eat a chicken every day or every few days. It's a lot of chickens. What else? Damien, turn your music off and join us. Come on. Come on, folks, come on. This is something you should be able to do. Try to think of something. I'm going to give you one. What do you think about that?
Yes.
Could somebody explain what this one means? Cole? Cole?
How old they are and compared to how tall they
But what about it?
are at that age, how tall they are.
But what about it? What's the relationship? No, this is good. It's Cole, that you're right. But what is the relationship?
The younger you are, the taller you get. Or the other way around.
So the older a person is, or how about this? I'm going to say it really simply. Older people are taller on average. How about that? Older people are taller on average. Is that always true?
No.
So it's a scatter plot. Because you might have somebody
who's very old and not very tall, and you might have somebody who's not very old and is very tall. So you're going to have these people who aren't in the average. But if you look at lots of people, it's going to be averaged until you get to adulthood, and then it doesn't really work anymore, right? Because like a 60-year-old is not necessarily taller than a 30-year-old, right? Okay, good. Anybody come up with another one? Noah, you've been really quiet. Are you with us? Can you think of anything that would work for this graph? You can't. Try. What does that mean, data plan? Say that again? I don't think so, because you're paying a certain amount every month. Different people, but it wouldn't be you every month. It would be different people for the number of months and the cost of their phone. Yes, in that case, you probably could come up with something like that. Cole?
Would a technic like paying for electricity and water, and you use more each month?
In general, the more months, the more your electricity is going to cost. But every house and every person and every month is a little bit different. So yes, that could create a scatter plot. Per donut or food or something. In general, the more food you eat, the more calories it is. But every food is a little bit different. So it's going to be a scatter plot. Very good. Okay. Look at, what's the difference between these two? Okay, good. What did you say, Cole? Okay, so I'm gonna go back and I'm gonna draw my circles around these again. What do you notice about where the first one starts compared to where the second one starts? So this one, what do we call that? Yeah, but and what's it called when it has a starting point that's not zero? Partial. So this one might be direct. We don't know. And this one might be partial. Okay? Can you think of something? Guys, listen. Can you think of something? Damien, can you think of anything that this graph would represent different from the other one because it's partial? This is hard, but. Tariq, leave him alone. So something that even for 0 has a value and then goes up from there, but would be scattered.
Pay $100. You start with $100 in your bank account.
Yeah.
And then you pay so if I have $100 in my bank, I start with that, and then I start. I have a phone bill. I pay $100 one month, and then I forget to pay my bill the next month. So
Maybe, kinda.
I don't know. So
Starting a job with about I'd say $50 and getting paid each week.
But your hours are different, so you're paid a little bit different. Maybe, kind of. Usually, we avoid money in these situations because money tends to grow in a uniform, kind of the same, or like, so it's a little, usually we're talking about different things in these.
Like the amount of points scored per game.
Compared to number of games?
Yes.
But 0 games would have 0 points.
that's not true. Because you're older and
You still can't score points.
Because if you have a season, and then the last season you played
Okay, per
300 points. Next
I don't,
season,
no, I don't know. I don't know that would work.
Then you start with 50 pizzas, and then you eat 2 pizzas a day. The next day you eat 4 pizzas a day. The next day you eat 12.
No, I don't think so, because that's growing linearly. You're going 2, 4, 6, 8. You're starting, and you're growing by.
Suddenly your pizzas start to go moldy and you start losing more each day.
So you go
How about
up,
this?
up, up, and
How about this? Yeah, you were supposed to just start, and then I was going to call. So it's there waiting for you.
Okay, I have a spare next, so I can just say go.
Perfect. So just get started. Do I need to call your teacher?
You can if you want. I don't think you have.
Okay. How about this? Sometimes when you're growing a plant, you start with the plant that's already grown. You don't start from a seedling. So you start on day 0, you have a plant that's about 10 centimeters tall, and then you have a bunch of them, and you measure their growth every day after that. Some of them are growing a bit faster. Damon, you got to take care of your butts out. You two, come on. We've talked about this all year. Do you understand what I mean? So you start with a plant that's already got a height, and then it grows from there. Maybe something like that. It's still increasing. Do you agree that one's still increasing? What about this one? So what? Yeah, you're right. Try not to shout it out. Noah, do you have an idea? I don't know if you've looked at it yet. Do you have an idea of what that might represent? Everybody can think about this. Don't just leave it to Noah.
Your bank savings.
So again, money is a tricky one. I wouldn't personally go with money for these. It's not the kind of thing that tends to form a scatter plot. Because look at these 2 points. Is that after 2 weeks? You can't have two different amounts of money in your own bank account after 2 weeks. So like each one of these points would have to be different people in different bank accounts. Like it doesn't quite, it doesn't really work for this kind of thing. I would avoid money. What do you think?
Like, let's say, like the iPhone X came out on the weekend, right?
Is this going to be about money again?
Not really.
Okay, go for it.
The amount of iPhone X's bought on the day it came out. So, like, the first day they sold, like, I don't know, 300,000. Second day they sold 200,000. And they continuously went up. And when it went to 3 weeks, after the first 3 weeks, they always sold about 100,000.
Yeah, very good. So that would be something. And every year that the iPhone comes out, it would be similar, but maybe a little bit different. So you'd get like a scatter. It's not going to form a perfect line. Good, cool.
Someone trying to lose weight.
How would that, go for it. Yeah, how would that work? Yeah,
Like, so they start out,
at
yeah, at
200 pounds.
yeah, and like they try to lose weight, but they're concerned that they're not eating enough, I guess.
Sure. Or it would be different people. It's not usually one person either when we're talking about scatter plots. So different people who all start around 200 pounds. Some of them lose a bit of weight. Some of them gain a little bit of weight. Some of them, yes, back and forth. Very good.
Number of people. You have 100 people in your family, and like 5 died. Jesus. What? 5 died.
So time. What about births? And number of people in my family. Yeah, not really. Yeah, time is per day. So this one is decreasing over time. Guys, you are not allowed to have separate conversations about other things when we're doing this. Yeah. So let's get focused. So this one is like decreasing over time. These two were both increasing. This one was partial. That one was direct. We can see that there's different kinds of relationships. One more to think about. What about this one? Looks like a taco. Very good. So this would be time, and this would be like sales. Like popularity could be sales. So a store opens and they have no sales, but they start gaining popularity, they start selling, and then something happens and they lose popularity and they go out of business. Sure. Anybody else? Cole?
Night to night cycle.
Daylight over time.
Yes.
So yes, so starting in the morning there's no daylight, and then in the middle of the day there's lots, and then it goes back down. Nice, I like it. Yep.
Oh, and you know what? Wait, she forgot.
That's okay.
Oh no, I got it. It should be like iPhone. They sell a whole bunch of iPhones. They start like selling a whole bunch of iPhones, like through the generations. And now everybody's already had an iPhone, and they're all practically making the same iPhone over and over again.
Possibly.
I have confusion.
So number of iPhones that they make or something like that. Yeah, that's possible. Okay. I sent out a message yesterday to make sure you brought your Chromebook to class. So I hope you got it, and I hope you brought it because we're going to use our Chromebooks for a few minutes. So get them out.
I'm sorry, I forgot it in my bag.
You should go see the technician about it then.
No, it's not that. It's because somebody hasn't paid it yet.
Oh, your internet at home.
It's gone. It's just stopped all the total.
If you don't have one, you can buddy up with somebody who has one. You could try it on a phone, but it'll be hard. If you go to the classroom, there's a link at the top, and you click on the link, and it'll take you to this. And we're going to do this. It should not take too long.
Where are we going? Go classroom?
Go to your Google Classroom. If you go to the Google Classroom, it's just the top link. It's at the top of our classroom, top of the stream. Pardon? DNA? Deribonucleic acid or something like that? Why? That's got nothing to do with what we're doing.
Kendrick Lamar has a very different point of view. What? Oh, I'm in the wrong thing. I'm in English. I'm in English. Yes. Every teacher's gotta watch me.
If you click the link, it'll do it automatically.
Let go.
Should I sign in?
I'm very, very
Go watch it. Every teacher needs to be on my case.
You click on the Desmos link. Take a look, folks.
That's it. In the bathroom, Caleb.
Just your first name, sorry. You can sign in with Google. That's an easy way to do it. And then it'll remember who you are and it'll save your work. Okay, folks. Stop and watch for a second. I want to show you something. What is the trend in the data on the left up here on the screen, on my screen? Tariq, up here. Caleb, you got to look up here. What's the trend? It's a scatter plot. What's the trend of the one on the left?
The one on the left is going down, I think.
Decreasing. And what we're going to do is we're going to very briefly practice drawing what we call lines of best fit. So you're trying to draw a line that's an average of your data. We call it a line of best fit. And sometimes people do it like this. Oh, I'm supposed to draw it through the middle of the data? Okay. What's wrong with my line of best fit?
Hold us.
It is very.
Hold us.
Yes.
Why are you going up?
Because this is, yes.
Doesn't make any sense.
Good point. It doesn't. But some people draw it because they always think it has to start at 0. So we want to show, Tariq told us that this is decreasing. It's getting smaller. So your line of best fit has to show that. Sometimes what I do, Cole, is I draw a circle around most of the points, and then I make sure that my line goes through the whole circle. Okay? And I draw a line through this circle, and I make sure it's going through the circle. Neither of these start at 0. Your lines do not always have to start at 0. You're trying to draw a line of best fit. So here's what you're going to do. There's 3 points here. Your line does not have to go through the origin. The line does not connect the first point and the last point. That's what some people do. They just go from one point to the other. They're just going to go from here to here. Okay, that's not a good one. What is the line supposed to do? It has to show the trend, like the circle. You try to get a bunch of points above the line and below the line. And if you can get a bunch of points on the line, that's good too. But it's really just an average. It's not going to be perfect. So what you are going to do, look carefully if you want to see what you have to do, is you're going to take these red dots and you're going to drag the line until you're happy with what it looks like. Folks, you're not watching. You got to understand what you're supposed to do. Emma, did you know that you were supposed to then click over here and click this dot here? You see what I'm pointing at? And that will show you how close your line is to the actual line of best fit.
Can you turn off one of the lights? I can't really see.
No. So you are going to make your line of best fit, and then you're going to open the folder and turn this on. Do that, okay? We're going to spend about 5 minutes. You should be able to get through it in about 5 minutes. Go.
Actually, you see stuff.
Yes.
If I hit it down,
How do I save?
You don't save. You just click next.
Alright.
Should I just like,
so
can I go to
confusing.
the next one?
Yeah, you just keep going.
Can someone help me? I don't even know.
Okay, are you happy with it? So then open this folder, right? Yeah, and then click that. Now click this little circle here. And that one's calculated. Yours is very close. You're not gonna get it. Yours is very good. Good job. Yes. You mean you don't get it? Were you paying attention when I was explaining what to do? What do you mean it doesn't make sense?
Oh, okay, that's where the other one. I thought we could only do it one way, but not.
So you're trying to see if you can get a line through those. And then you check.
Psych.
Click this little dot.
It's
how did
like
we
this.
go back?
Remember you wanted equal for the ones above and below.
Go back. Oh, you didn't open that.
Okay.
You didn't turn it on.
Yeah.
So you're not opening it. Yeah, so those ones are off.
Hit her up. Hit her up. Oh. Hit her up.
This is the first one. Do it again.
I think this is the first one.
That one you were really close.
So,
The next two.
You like the hand.
Like I can go back and fix it. Just not keep going on and do that. This stuff specific.
see how, yeah. See how the others are. Again, everybody's line best fit isn't going to be exactly the same. And that's okay. Did you try the next one? Try the next one.
Somebody skipped a whole bunch and didn't.
I'm that one. I'm that one.
Don't do that. Don't skip them. Do them all.
The top one.
My name is apparently.
Well, did you freeze it?
It's frozen. Yeah.
Don't skip it. No, you gotta go back.
Don't you understand?
Now, open the folder. This is an important part. You gotta click on that little triangle, and then you gotta turn this on. That's what I was explaining in the front. So you can compare your lines with the lines. See how close you are. You happy with it? So then you gotta open this, right? Click this dot, you should be able to see what you can't for some reason. Oh, yeah. You wanna zoom in?
I got beat up when I was 18 years old. I beg your pardon if I'm freaking. I got beat up when I was tall. He's like 17 feet tall. It's like David versus Goliath. I don't have a slingshot.
Now you can see it. So you gotta turn this on, so you can see the blue line. Whoa! The blue line right
That language is not okay in this classroom.
Well, I tripped. He's like,
You swung and you missed his whole head.
Guys, we're doing an activity right now. Come on.
he just slapped me in the eye the whole time. Literally.
Three.
No, I'm here.
No. But listen to what I'm saying. It doesn't matter. I'm gonna give you get this finished. Folks, I want to show you something.
So can you
Stop what you're doing for a minute and look up here. Caleb, turn around. Caleb, we're not talking about fights and stuff anymore. Forget about it. I want you to look up here. This is the first one. What would you say about all those red lines? Those are all of our lines.
They're all wrong.
And the blue line. They're all a bit wrong, but what would you say about them?
They're very,
Similar? Pretty close? Similar enough, I agree. Take a look at this one. This is the next. What would you say about those lines? Look up here, folks. Vanjit, stop what you're doing. Look up here. Tariq. What would you say about those lines? They're not as similar? And they're not as similar to the blue? Let's take a look at this one. Same thing. In fact, we've got one going the entire opposite direction. Somebody's still moving it. This one's going, these ones are mostly going up there. Why do you think sometimes the lines are close and sometimes they're not?
because sometimes they might be like,
Okay, so a couple more minutes to try to finish this activity. We're going to move on. So get through the last few, and when you get up to 10 and 11, you have to type something out. So I want you to do 10, 11, 12, 13. I want to make sure you get those done in the next minute or two.
I don't remember. A long time ago.
It's good.
I didn't know how to make some of these stuff. I didn't even care. I'm just making sure that damn done now.
Look at how long that is. But see, did you even notice that? That point is still. And changes the math, but it looks to me like there's something wrong. Your line fits this data really well. This one is skewing your data, you know what I mean? Okay, you should be pretty much done. If you get to
16, where the points are all huddled, you're supposed to actually read what to do. Looks like people didn't. And you can drag the points to make your own scatter plot. Yeah, for 16 and 17, but you don't have to. That's just something to do if you get done and you're waiting for everybody else. And then you can make your own scatter plot and see how close you got. Okay, I want to look at something. So I think we're going to be done, and I want you to close your Chromebooks up. If you're not all the way done, you can finish it later, but let's get our Chromebooks closed so you're watching here. We're only spending one day on this. So you got to be focused enough today to kind of hear all the little things. With linear relations, we spent a lot of days on those ideas of rate and where it starts. And so if you were kind of, if you missed Monday, then you could pick up on it on Tuesday or Wednesday maybe. But there's only one day on this. So you really got to make sure you're paying attention today. Everybody good? Close your Chromebooks all the way. Thank you. Phones still away. So this was number 10. And this was number 12. What was the difference between the points in 10 and the points in 12? There's 12. There's 12. Sorry, there's 10. And there's 12. What's the difference? 12 is a very close straight line, and 10, the dots are quite scattered. When the dots are quite scattered, it's hard to make a good line of best fit. And you can see that by everybody's lines all over the place. When the dots are really close, like some people drew their lines, maybe you weren't finished, but you drew your line all the way below all the points. That's not a very good line of best fit, folks. In this case, you should be able to get a line that's very close to the actual line, because the points are all very close together. So your line should pretty much go through them. Does that make sense? So if you're going to listen to anything all day today, this is one of the things you want to listen to. When you're drawing a scatter plot, it's hard to draw a really good line of best fit. But with a little bit of practice, you can do okay. It doesn't matter if you're perfect, but if the dots form a really close line, you should be pretty close. If the dots are quite scattered, it's going to be a lot harder. Let me show you kind of what I mean, and then we're going to move on. See how mine goes kind of right through all of the points? If your line was like this, that's not very good. Or if your line kind of cut through the data, so there's a whole bunch below here and a whole bunch above here, that's not very good. It really should cut through as many of the points. So I only have a couple above, a couple below, but most of them are kind of on the line. Do you see that? And then if I check, look at how close I am. Right? Because the points basically form a line. So my line should go through those points. Compare that to this one. That, I don't know, it's way harder. Like, that kind of goes through, so that's about as good as I can do, and it's not very good. Even the teacher can't do a great job with this. If you're just eyeballing it, it's very hard. But don't you agree that those points are decreasing? So your line should be definitely decreasing. Okay? If you drew this line on a test, even though it's pretty wrong, you get full marks. If you drew this line, you would not. Because that's not showing the trend. Those points are decreasing, your line is going up. Wrong, wrong, wrong. All right, here's what we're going to do next. Okay, just listen carefully. So we're going to make a scatter plot. But to save some time, most of this one is done for you. You only have to plot the first point and the last point. So I believe these points are these ones. All done. So you just have to do that one and that one. So go ahead and put them on. If I spent 4 hours studying, somebody spent 4 hours studying and got 65 on their exam. So I go over to 4 hours and I go up to 65, and it's not a perfect line, so I just put a dot. And then somebody spent 6 hours and they did a bit better. They got 77. So I go over to 6 hours and I go up to 77 and I put a point right about there. So hold on. Don't do anything yet. Has everybody got that? But normally you'd have to plot all the points. Yeah, like on a test you're not going to have to plot 100 points, but like I did this just so that we could kind of get through this. But if you're given them, you have to plot them all and look at how they're kind of scattered. But what's the relationship? So now you're going to use a ruler, please, to draw a line of best fit. Always use a ruler. But before you come up and get one, hold on. Go sit back down. This is what you're going to do. You're going to take your ruler and you're going to put it on the page. And are these points going up or going down? So I'm going to start somewhere around the beginning, and I'm going to make sure it's pointing up. And I'm just going to take my ruler, and I'm going to kind of nudge it up and down and nudge it back and forth until I've got it in a way that I'm happy. And then I'm going to draw a nice straight line through all those points. Okay? Okay, you can grab a ruler now and go. Who wants this one?
I'll take that. What I got.
Why did you guys move back there? Come back and sit in your spots. Let's go, folks. This shouldn't take very long. Yours does not have to look exactly like mine. Do your own. Don't just try to copy mine. But then you can compare if yours looks like mine or if it looks like somebody sitting beside you. Compare yours to theirs. That would be interesting because sometimes they're different. If you want to take a look, mine did kind of start touching the first point, but it does not have to. Just because one person didn't study at all, there's this point 0, and they got a 33 on the exam. Not very good. But just because one person did it doesn't mean everybody's going to get that. Doesn't mean the line has to start there. You might not study at all and get 33, but somebody else might not study at all and get a 50 because they worked hard all year. And without studying, they at least passed. Somebody else might not study at all and they might get 20%. Do you understand what I'm saying? Let's see, is there an example? Two different people might both spend 5 hours studying. It doesn't mean they're going to get exactly the same mark. It's not a perfect relationship. There's no guarantee that if you spend 5 hours studying, you're going to get this mark. But in general, don't you think if you study longer, your mark's going to be higher? No?
Overstudy.
You don't believe that?
Overstudy.
Most people will believe that the longer you study, the higher your mark is going to get. Sure, there are exceptions. And you could overstudy. You could overprepare and get tired and do bad. Like there are other things at play.
But in general, the longer you study, the better you do. This person studied more and got a worse mark than this person. This person studied for 2.5 hours. This person studied for 3 hours. But their mark was a lot better. What does that tell you about those two people? They got lucky. Maybe they worked harder throughout the year. Who knows?
Maybe they're mean.
Draw a line of best fit. So we've done that. Describe the trend of the data. So for one, it's increasing. But if you're ever asked to do this, folks, you're supposed to say something like, on average, the longer you study, the better mark you get. Studying longer gets a better mark. The more you study, the higher your mark. Something like that. Talking about the two labels, right? Like this is mark and this is time studying. So when you are describing the trend, you should be mentioning those two things. As this increases, this increases. Or as this increases, this decreases. What would that mean? Those other ones that we looked at that are going down. Use your line of best fit to predict what mark you expect someone who studied 9 hours to get. So I go over to 9 hours and I follow it up. And if you have to, you can use your ruler, but there's already a line. And I'm actually going to draw a little point. And then I'm going to take my ruler and I'm going to try to make it perfectly horizontal. You can't see what I'm doing, but I've got it on my screen. And I'm going to follow it over like this. And I'm going to see where it goes. So about 95. Pretty good. Yeah. So this is the nice thing about a line of best fit is we can use it to make predictions. If there was somebody who, actually I think that's going to come up, so let's just do it. Use your line of best fit to predict what mark you would expect somebody who studied 2 hours to get. Look, there is somebody who studied 2 hours. I don't just pick that person. That's one particular person. We're looking for the average. So, oh darn, I erased my whole line. So I follow 2 up to the point, and I follow it over. And I'm saying it's a bit over half. So I'm going to say about 46%. Even though there was a person who got 50, my line doesn't show that. My line average says that person got lucky and did a little bit better. Usually you'd get a little bit worse. Doesn't that make sense? Some people will be above the line and some people will be below. What's the average height for a 14-year-old?
5'4".
But some people are taller and some people are shorter. Right?
You're not 5'.
Any questions? Everybody okay? And then we can flip it around and we can use our line of best fit to predict the number of hours somebody studied if she got a mark of 65%. So I go to 65 and I follow it over. And it's right about there. And then I follow that down. And it looks like a bit more than 4.5. But if you said 4.5, that would be close enough. 4 is not, 4 is a bit too far off, I think. About 4.5 hours. Because 4, it goes through right there. So 65, looks better than that. Okay. You can guess for sure. Scatter plot below shows data from an experiment. Which of the following best represents the trend in this data? A line that starts at 0 and 10. and ends at 1.5 and 0. I mean, it's not great. So A, I did in blue. B, a line that starts at 0, 0 and ends at 1.6 and 12. No. A curve that starts at 0, 10 and ends at 1.5 and 0. I'm going to get rid of this. So I'll make a red one now. So a curve that goes like this. Actually, that's a bit better, isn't it? A curve that starts at 0, 0 and ends at 1.6. So that would be something like that maybe. Definitely not that. Which one do you think? The line, the blue line, or the red curve? The red curve. The red curve, I think, is the best approximation. So something in grade 9, we don't do a lot with curves, but sometimes the data clearly shows that it's curved. And this one does look more like a curve than a straight line to me. Like if you just look at those points, they kind of look like they're like if I draw a curve, I go through the points better than trying to draw a line through them. Which scatter plot shows data with no trend? Why do you think C? Very good. This looks like a curve. This is decreasing. This is kind of flat, but they're still kind of clumped together. This one, they're just all over the place. Good job. Any questions about that?